there is a better way to integrate. You would have learned about Riemann integration in school. Roughly speaking, you divide the domain into intervals. From each interval, you take a value, let's say the one which gives you the least value. That becomes the height for your rectangle. You add up all these rectangles and you get an area, and the integral is the limit of this area as the number of partitions goes to infinity. Lebesgue integration, on the other hand, does something kind of fancy. It takes the value of the range and sees how much of the domain contributes to that value. Let me be more precise. Let's take this function and now let's partition the range. Take a particular interval. Let's see which all values of the x-axis map into that interval, or rather the length of all the x values which map into that interval. Then the area of that chunk is roughly the length that I just mentioned multiplied by a value from the range. Let's say the least value. Then you do this for all the chunks and you add them up. The Lebesgue integral is the limit of these sums. Now let's take a concrete example. This function is a variation of the Dirichlet function. It is 1 when it's irrational and 0 when it's rational. Let's try to find the Lebesgue integral of this from 0 to 1. It boils down to the length of the values which give 0 and the length of the values which give 1. So the Lebesgue integral equals 1 times the measure of the irrationals in 0 to 1 plus 0 times the measure of q in 0 to 1. The measure of q in 0 to 1 turns out to be 0, and therefore its complement, the measure of the irrationals in 0 to 1, turns out to be 1. So the Lebesgue integral of this function is 1. The advantage of the Lebesgue integral over the Riemann integral is it's lots of analysis reasons, calculus, limits stuff becomes easier. I'll not get into that in this video. But I do want to end with a beautiful quote by Henry Lebesgue himself about his own integral. I have to pay a certain sum which I have collected in my pocket. I take the bills and coins out of my pocket and give them to the creditor in the order I find them until I have reached the total sum. This is the Riemann integral. But I can proceed differently. After I have taken all the money out of my pocket, I order the bills and coins according to identical values, and then I pay the several heaps one after the other to the creditor. This is my integral.